I guess we're live now on Twitch. So welcome everyone who joined us now for this live stream on Twitch. We're excited today to have Martin Kirst, who is one of our community members, to join us today for this very interesting talk. We've been talking about clients for Hazelcast, and Martin's contribution to the Go client is really important. So welcome, Martin. How are you today?
I'm fine, thanks, Fawaz, and hello from my side as well. And I'm glad to say hello from Hanover, Germany.
Yes, welcome. So I believe it's like 4 o'clock in your local time.
Yeah, shortly past, true.
So you're basically a software architect for Oliver Wyman. Perhaps you could do like a little bit introduction about yourself. What do you do?
Sure. Yeah, my name is Martin Kirst. Actually, I'm living in Berlin just today for a visit here in Hanover. I'm software engineer, software architect by heart. I made my hobby to my profession. I'm coding software since 30 years already, and it still gives me a lot of pleasure on my day-to-day work. I worked plenty of years in the finance industry, also in the weather business, where if you, for example, by today, if you watch BBC weather and see the weather data there visual presented, so to say, then I'm glad to share that I contributed to the weather API, which feeds the whole BBC weather data system. Nowadays, and with Oliver Wyman, I'm more focused on the energy retail business, where I'm supporting our clients in building platforms for, like customer management platforms, which has an extra challenge in the German market when the energy regulations need to be implemented in a correct manner. This is what drives me job-wise, so to say, and when I'm not working for Oliver Wyman or contributing to Hazelcast code, I build and fly drones like this one here. It's a freestyle drone. It's a quite fast one, like 180 kilometers per hour plus. And when you fly at that speed and have a wink with your eye too long, you crash. So I'm also spent plenty of time in repairing them. Yeah.
Yeah, that's great. Actually, we were discussing yesterday if there is an application which runs drones using Hazelcast. So that would be an interesting project. I didn't know that you have this hobby.
Now you got my attention.
It's really something. So may I ask you what you got interested in Hazelcast? How did you know about Hazelcast?
Yeah. Also in my spare time and related to the client work I'm involved, I'm over the last years developed plenty of code in Go. One of my projects emerged out of the need that in the Go ecosystem there's no good library available for handling workflows according to the business process model and notation standard, the BPMN standard. And from my experience, I realized that this is a very battle-proof standard and compared to other ones. And I thought, hey, that's missing in the Go ecosystem. I enjoy coding, so I started writing a library, which actually implements an execution engine for such BPMN compatible workflows. And while I did though, and while I said it's also just a library which is supposed to run in a Go application, I felt this visualization requirement is simply, very big of a feature and something I don't want to do. And I looked into the market and figured out there are other open source projects already which operate on event streams and visualize workflows. I've brought a demo today and we'll show this later as well. But just to continue in the explanation here, the idea then I had is, what if my library would just export into this visualization tool? And this is where I met Hazelcast, because this visualization tool called ZB Simple Monitor uses Hazelcast underneath to get the events provision, so to say. And this is where a touch point. And back in the days when I started the library, Hazelcast supports for Ringbuffers in the Go client SDK was not there simply. So I did it. And so we met.
Yeah, that's great to hear. So from your experience, are there any differences between your day-to-day coding and contributing to open source projects? Are there any differences between these two or same?
Definitely. Here I'm very glad to say that from my perspective, what Hazelcast is doing in terms of community engagement and supporting the community is really outstanding. I do contribute quite a lot. If you sneak peek my GitHub profile, you will see. But really, without getting red ears, but Hazelcast is doing a very, very good job here. In contrast to my day-to-day work, it's getting closer since over the last 2 years, the remote work obviously increased in our business. But still, in my day-to-day work, I know the persons better and, let's say, have a stronger relation with whom I code. Whereas in the open source community, it's still a bigger grade of anonymity. It takes a bit longer until one gets the relationship established, same as in my day-to-day business. They are simple. Yeah, that's one of the differences which immediately comes to my mind.
That's great to hear. So I know a lot of people are listening and watching us now, and maybe they are interested in contributing to open source or Hazelcast. So what advice would you give for people who would like to contribute to open source projects or even Hazelcast?
Yeah. First rank, just do it. Now, jokes aside, I think the easiest way is where you feel comfortable. When you look at the projects you are familiar with, just sneak peek for a second into their, let's say, open issues, and see if there's like a quick win. Some maintainers highlight in GitHub the open issues with a good first issue. It's a very good indicator where you can expect a low entry barrier and just start going. That's probably the easiest thing to start, because you know the context, you might already know the library to some extent, and then it's way easier for you to get into it actually.
Mm-hmm. Yeah, that's great to hear. I think people will be more encouraged to do or contribute after this talk. So I think now we can jump over to basically the meat for this talk and see basically your contribution. So I will hand over sharing the screen and everything to your side. So perhaps you give some kind of introduction to, the subject and your contribution and how come it came to light to make this contribution for the Go application using Ringbuffer. So it's open. Thank you.
You're welcome. If I know there's you read the chat in parallel, which I can't read while sharing, but please just head out with question. Would be more than glad to answer spot on, so to say.
That one's one notice here. So I will be monitoring the chat from my side. So people feel free to leave any question you have for Martin, and I will just forward these questions to Martin as we go along. Thank you.
Yeah. Right. Then maybe let's start with what we want to see at the end of our demo running, so to say, the visual aspect. The ZB Simple Monitor is from the Camunda community hub organization on GitHub here. It's a non-commercial open source product. It's based in Java, and it's supposed to visualize workflow events in terms of BPMN, as I said, this workflow specification. When their broker is running and events emitting, they want to monitor these events in a visual way. I have this prepared already. So it would look like, if you, I come to the setup in a second, but if I now have defined a workflow, I see here 2 instances which did run. And if I click on one, for example, then I see here on one hand side in the middle, obviously, this is the very simple Hello World workflow I just had developed a few minutes ago. This workflow was executed and all 3 steps did pass. So this is how I read this annotations here. That's quite straightforward, I would say. And if you're familiar with workflow engines, you can easily imagine that beyond Hello World, there are way more options possible, what you can actually do in real world business requirements sense to implement such a workflow. This is what I wanted to have for my library in terms of visualization, and I was absolutely too lazy to implement this on my own. If we are, period. Back to the architecture, just to highlight again, even if it's called broker here, you can think of the broker itself as the BPMN engine, the component which actually executes the workflow one had designed in a modular. All events which are emitted there are pushed forward via a Hazelcast Ringbuffer into the monitor. And for your understanding, I can show I have this running in Docker, the same setup with these 3 components. The broker is running in this and that version, the monitor is running, and Hazelcast is running. This is like regular Docker images, fully open source and freely available, nothing special here. If you're interested, I can share afterwards as well the setup for such, if you want to go and explore deeper this such a setup. Right, what I did, the BPMN engine I wrote, maybe it's better shown here. I had the idea I would just have a BPMN engine which operates on standard workflows in the BPMN 2.0 specification and is able to embed it into your application. I don't want to attach any database nor anything else because these are too many dependencies. Just the pure execution engine you want to have with minimal dependencies executable in your Go applications. That was my main motivation, my main goal, and this is why I started roughly 1.5 years ago with this project. There's plenty of documentation out there. I don't want to go too much into that, but we'll show you a little code example. So you can, from the diagram I showed, you can directly correlate the broker is meant to be and replaced now by my BPM engine. I have an example application. You see here, this is just checked out from the main branch from GitHub. I closed this that we are not getting distracted. There are some example snippets already there. And for this example also here, and with a bit more detail, you now see the whole architecture again with the right syntax, so to say. My demo app runs as a Go application, publishes the event to a Ringbuffer which runs in Docker, which then get connected from the web app from the simple monitor. They are synced on the Ringbuffer and it's stored in the database. The right hand side is everything in Docker. We don't need to care, but this is how they interconnect. The important thing for a Ringbuffer is that there can be many publishers and many readers from the Ringbuffer, and they all synchronize here on the single Hazelcast instance, which is running in my Docker. This makes it quite easily, and the main benefit also from that setup is that imagine in a real world scenario, you want to update a version or like a new deployment, a new version of your app, because it's Ringbuffer as such are not also usable for you as well. If there's a downtime of the monitor and in the meantime the libbpm engine would publish more events, the Ringbuffer is literally buffering them. And if the monitor app is coming back to life, it will resync from the buffer itself. So you have an absolute guarantee that you don't lose any events. And this is also one of the main reasons why Camunda before me even decided to use and leverage Hazelcast's power here and the features from it. So building on top of these giant ideas, so to say, a very simple BPMN application in Go could look like. Again, here you see the simple, I opened this simply in the monitor. I have, this is again the simple world workflow, right? You have a start of the workflow, a simple service task, which is supposed to execute something, whatever this is not specified here. And there's an end of the workflow. Straightforward, hello world, do something, done. In our example application here, I need to set up first a few connections to, for example, here, line 17. I can also zoom a bit in. Hopefully you can read them better. On my Hazelcast instance running locally, I need to connect, obviously. This is quite straightforward here, line 17. And I skipped that one, I apologize. The BPMN engine needs to be instantiated. That are like the minimum requirements you need in terms of network and setup you need to make. For my engine itself, you need to specify that you want to have an exporter set up and defined. So because the architecture of the library is flexible enough to support multiple exporters. And here we can say the setup is done. And from that moment on, the BPMN, the simple task workflow here, can be loaded. And after loaded and a few task handlers are configured, which just, they do nothing, right? It's just it's a handler defined. We simply execute it and that's it. So loading a workflow, instantiating, executing, and being happy and done with it. Before I press the play button, and I hope the demo gods are with me, just for a second, back to our main view. From a few tests I just made before, we can now see there were 2 instances up and running a few minutes before. The creation time is a bit earlier. We remember 2. And if I now press the magic please run it button, fingers crossed, that looks good. A few logger information or log information that the cluster connection did happen, the member size, blah, blah, all good. Instance key, that sounds great. No error message if I reload the page. Here we go. In the back, the BPMN exporter successfully pushed the events to Hazelcast, and our monitor here grabbed it, and surprise, they are now, instance executed. And wow, to prove that this is no cheating, we now simply do a little modification. We simply define a second task for this simple sake of something needs to happen. We also say that's a service task. For every service task we define, there must be a handler later on defined. That's one of the rules in a BPMN engine. So I overwrite and make precisely the ID equivalent to the name. Then I say save. Now back in my simple application here, I'm lazy and say I register a new task handler for goodbye for the same ID, and let it be the same handler. it's really important in the BPMN environment that a handler is defined, because if there is no handler, the workflow will simply not complete it. It will stay open. We can test this later, but let it run first. That looks nicer. And the handler itself is more a dummy handler. It just says complete. Quite straightforward. And without further doing, I press replay. Looks good. Reload. Second instance. Fourth. So, oh damn it! The demo gods. But we can at least anticipate there was something happen, but something went wrong. Okay, my very likely my fault, not the Hazelcast. But yeah, at least it was created. Let me change it back then. It definitely should work again. Just rerun. Reload. Fifth. Yeah. Oh. Okay. Yeah. I checked out the main branch, not the release version, I have to admit. Yeah. Cool. Are there, maybe in between, are there any questions by any chance?
Not at this moment. We don't have any question yet, but I will just collect questions and I will ask all the questions towards the end.
Okay. Yeah. From your perspective, Favas, are you interested in any direction, digging deeper into that code, or jumping towards maybe looking more deeper into Hazelcast?
Yeah, I would be more interested in diving deep down in the code so people understand exactly how it works and then how it's connected to Hazelcast.
Then we're going one level deeper. Right, there's one more detail. Right. We are now entering the details of the exporter from my engine here. Before we go into that, maybe it's worth to look at such a struct. If you imagine, and we can better show this here. In the XML and not in the not in the visualization. It looks a bit scary in a first rank, I have to admit, but I will explain in a second, and I hope it gets a light bulb up in your head. The BPMN specification based on XML is quite old. There was no movement in the specification since the last final release in 2014. But this has rather not the reason that it's a dead technology, but rather battle proven, because the specification itself allows very much everything to model in BPMN itself. This is a very comprehensive specification. That's why I also looked into it. And one of the things which makes it charming is the way how it's constructed in XML, because it mimics a kind of execution environment similar to what you see when you look into CPU design. So there are like states and state transitions. And states, in this sense, they are, even if it's a quite broad term, these states express itself in, even if they call it here a start event or service task, but these are all in the sense of BPMN called activities. So every visual element, we see here 3 visual element, is called an activity. And if I have 3 activities now in front of me, I can see already by the arrows there's a transition in between. So you can model an execution engine similar like you would model an execution engine for code, like a CPU or the Lua runtime or simple things like that. There's very strong conceptual similarities. And one of the things which are important, for example, for a service task, is always the ID. And when you have an ID, some definitions, and you have here the incoming and outgoing flow links highlighted already. So you literally can traverse through this XML like through a directed graph. For the ones who remember the first lessons in computer algorithms. If you Google a directed graph and graph traversal, you find plenty of examples. It's quite an interesting domain. For now, I would say, if you imagine jumping through all the states and doing the transition, you naturally emit events, and these events always contain some meta information. For example, if I have instantiated a workflow into a single instance, then the instance has an identifier or a key. And next to the key, I might have a creation time, and so you always have this metadata. And all this metadata must be added to each and every event which gets emitted. And this is what we see here now in front of us, that we craft a struct in Go, which contains all this metadata, like timestamps for now, so to say, for this blah blah. Here, this is what I meant: the process ID itself, the version from what I uploaded it, the definition key, the resource name, checksums. This is all metadata, and this is supposed to be a new process event. So it tells, for the visualization part, exactly that, a new process. This is a new process. And so we see the process ID, the version, and the counting here is made by the visualization tool itself. But you see how these elements here, which are supposed to be visualized, emerge out of this data struct, because it's exactly process ID, version, and definition key, and some other meta name. What I craft here in terms of process record is very much Camunda specific. As I said in the beginning, I leverage the existing ZB Simple monitor, the visualization tool, so I have to speak the protocol they use in terms of event communication. And this is where they offer, also in one of their open source projects, linked from GitHub, they offer this protobuf definition. And what my library actually is doing, it mimics the exact behavior of the Camunda engine in terms of it crafts these events and then emits them via Hazelcast for the monitor. And yeah, period. In other words, it means my exporter here is a Camunda engine simulator, if you want to say so. I hope this makes some sense.
Yeah. Okay, so we got a couple of questions, if you don't mind.
Yeah, go ahead, please.
First of all, are you using or are you planning to use Go generics?
They are, yeah. The Go generics definitely are an interesting extension with the latest release. So far, I'm not using it, but I'm very much looking into, because especially here for my BPMN engine, I had to do some workarounds before generics appeared in Go to operate on the activities, as I said, because in the specification itself, it's written a start event, a service task, and an end event. These are all activities. But you see here already they are differently named in terms of, they have like an inheritance model in the specification, which was very difficult to implement in Go. My hope with generics is that I now can better reuse code I already have written for traversal here on different elements, but with the help of generics. Definitely interesting. So far, I unfortunately must say no.
Yeah, that's good. And the other question is, what is the libbbmn requirements?
Requirements are quite low, I would say. Obviously, it's supposed to be a Go library. It has on its own, and for the Go application including it, it has just very, very few dependency on its own. At least, yeah. You see, it's just a handful. If I exclude the dependency for testing, then we just have 5. Beyond that, memory and CPU requirements are pretty low. Go is built on top of C, if I'm not fully wrong, and builds static binaries, which have a very good reputation consuming little memory and CPU. If I never measured it, but from similar projects of mine in my business environment, I know that with 20 memories of RAM, and if you are in Kubernetes having just 100 micro CPU configuration, so really microservices, you can already start having a Go web service with libbpm in place and would be able to work and operate tasks already. So that's, yeah, 10th of a CPU core, really small requirements.
Yep, thank you. So I think these are the questions. Are there anything else you want to mention?
Nothing what jumps straight to my mind. I mean,
Okay, so
if you're interested, yeah.
What are the future plans?
The project plans. The engine itself, from my perspective, is still a beta release, beta status, I would say. There are a few features missing. I have a little project. Sorry, not project. There are milestones, and the milestones are visible in the issues. There are a few open items for my release 030. With these ones, I would consider coming out of beta status, going into a release candidate. One of the major features missing is the ability to serialize and deserialize workflow instances with the library. Prime use case would be that, imagine you have a microservice for ordering something. Obviously, in the real world, every payments, shipments, shipment tracking, and so forth, these are asynchronous by nature, by design. And you want to be able to, once a certain step in your workflow is processed, you would like to pause the workflow until a new event arrives. And so far, the library is not able to somehow store in-flight workflows. So you would have actually the requirement right now having your service 24/7 running, and the reboot would kill everything. So serialization and deserialization, or storing it into a database, is the last feature I have on my agenda before going into any kind of release candidate. Mm-hmm. The interesting, I mean, that sounds in a way strange, right? That's beta. That's not even, and so before it was alpha, and before it was just a crazy idea. And nevertheless, I'm really proud and also glad to say that, I mean, 99 stars, that shows interest, and I had a few contributors already, which is really, really cool. I'm more than would be more than happy if more people are interested and maybe want to contribute here and there a bit. That would be really awesome. I also already got some LinkedIn say hello messages from people who build similar stuff, maybe in other languages. So there's definitely a very living, full, colorful community out there where everyone who's interested in workflows itself can really learn from. And I also plan in March, there's a Camunda community conference. I plan to demo my engine there as well. Might be a bit of a competitor to their commercial offer, I know. But the interconnection from a foreign engine in a foreign language with their simple monitor got quite a lot of attraction, and they are really also interested in making somehow community standards and enabling more tools to operate with BPMN, because the specification itself is really powerful. The tooling itself is good, but could be even more improved. And this is where the whole community, including also the business, would benefit from. And this is where I also hope we will see more movements in the future.
Yeah, I totally agree in terms of the contribution. I think the more people use it, the more contributors you will get, and definitely like doing talks and doing live streams will definitely help. So we'll be looking forward to see future updates from the live engine here. And in terms of Hazelcast, anything else you would like to contribute to Hazelcast, or you see like something interesting?
Yeah. There's one thing a bit more down the road of my priority list, but if I have some spare time, I definitely will extend the visualization in the admin console of Ringbuffers. This is also a bit, the last time I looked into it is a bit longer ago, but still missing if I'm not fully wrong. Yeah. And then that would be really cool to see in the admin console the events itself.
So that would be great actually to see in the near future. So thanks very much, Martin, for your time and for your contribution to Hazelcast. It was really nice to finally get to talk to you and speak personally about your experience and your contribution. So from everyone from Hazelcast, thanks very much for today's live broadcast and for your contribution.
It was a pleasure. Sorry?
Anything you would like to add before we finish?
No, all good. It's I'm glad we had a chat here also, sending out and streaming out to the community. Looking forward to anyone, just ping me if you're interested, or Havas, or we join forces for the Hazelcast next contribution. I'm in, so to say.
Yeah, so with that being said, I would just like to remind everyone that Martin is available on our Slack community channel if you would like to join our Slack community. And also you will get access to the blog post written on the Hazelcast blog. So you can see also Martin details if you're interested to reach out to Martin. We will be hosting our first live community event in March. So if anyone would like to contribute or attend, it will be on the 9th of March. It will be great if we can see all of you there, and we will join you next week basically for another Twitch live broadcast about machine learning. So thanks very much, Martin. Thanks to everyone for attending.
You're welcome. It was a pleasure.
Yeah.
Cheers.
Bye.